capacity to do work. It is capacity to perform some work. We talk about the light energy, we talk about the heat energy, we talk about the electrical energy, we talk about the sound energy, we talk about the nuclear energy, we talk about the thermal energy. All the energies, they are same and their unit is joule only. So unit of energy is joule, and we also have said that is work and energy, they are interconvertible. Work can be converted to energy, energy can be converted to work. So there is conservation of energy principle, which says that is sum total of whole energy of this universe is constant, and the energy can neither be created nor be destroyed. It can simply be transformed from one form to the other form. It means the total energy of the universe is constant, and you can only transform the energy, that is from sound energy to light energy, you can change it, light to electrical energy you can change, you can do all those changes, you can do it, but you cannot create energy. But this was the era of Newtonian mechanics, when all the velocities, they were very less as compared to the velocity of light, that is 3 to 10 to the power 8 meter per second. But then Einstein and the work was done on relativity also, though Newton also has started work on relativity, but recently there has been so much work which has been done on relativity, be it what you call Einstein's general theory of relativity or special theory of relativity. So over here now we are talking about the velocities of the bodies which are comparable to velocity of light. So now it is quite possible, nuclear fission, you know that is what are nuclear bombs. Over there the mass can be converted to energy, that is mass effect, and it can be converted to energy also, that is so much energy is liberated. So that is, there is a conversion of mass and energy also. When the gamma rays, high energy beams, they fall on heavy nuclei, then they produce electron and positron. Positron has the same mass that of electron, but the charge is positive to that of electron. So when the energy falls on this gamma rays fall of heavy nuclei, then the electron and positron, that is the mass is created. But this mass is so unstable, once again they revolve each other and give out the energy, that is in terms of gamma rays, the energy is liberated. So over there we see that is energy can be converted to mass and mass can be converted to energy, and this is what we are talking about, the relativistic mechanics also. So when we had been talking about the Newtonian mechanics, where the velocities, they were very small as compared to velocity of light, we can safely say that is energy can neither be created nor be destroyed. It can only be transformed from one form to the other form. But when we are talking the relativistic mechanics, and that is the reality, then we say that sum total of mass and energy of the whole universe is constant, and they can be converted from one to the other form. They can be converted, energy can be converted to mass and mass can be converted to energy also. But over here we are primarily talking the blocks and pulleys, bodies which are moving at velocity of 10 meter per second, 20 meter per second. Even the escape velocity is maximum 11.2 kilometer per second for Earth, which is very small as compared to 3 into 10 to the power 8 meter per second, that is the velocity of light. So we can very safely, we are in the domain of Newtonian mechanics only. So when we talk about energy in Newtonian mechanics, we are primarily interested in mechanical energy. What is mechanical energy? Mechanical energy is sum of potential energy and kinetic energy. So let's write over here. Now when we talk about potential energy of a body or system is because of either because of its position or configuration. When we talk about potential energy because of configuration, it is something like this. Let's say there is a spring over here, and if you pull it, then some energy gets stored into the spring. It will have a tendency, that is once you have pulled it, then you can put a block over here and this will pull the block in this direction and will give it motion. Or let's say in earlier times we used to have the watches where we had to wind the watch so that it keeps working. The energy was stored in the spring, and that is the energy which is stored because of its configuration. The other potential energy is because of its position. Let's say we talk about the gravitational potential energy, which is because of mass. Whenever there is a mass, it creates a gravitational field. Gravitational field interacts with the gravitational field, so that's why whenever we have two masses, there is some interaction energy. There is interaction energy of the system. This is the potential energy. When the particles, they are interacting, when the charges they are interacting, then we have electrical potential energy. So we have electrostatic potential energy, we have gravitational potential energy, we have this is because of configuration we have. So these are various kind of energies, and we are primarily right now when we say the potential energy, so it means we are talking of the gravitational potential energy, and that is mgh. This is mgh, where m is the mass of body, g is acceleration due to gravity of earth, h is the height from the reference level. We are not talking the great heights, that is a body has been lifted equal to radius of earth, that is 6400 kilometer, that is the radius of earth. We are talking the heights to which the body is moving as very small as compared to radius of earth also, because when this heights they are very huge, then once again we'll see that the acceleration due to gravity that will be changing, and once again we have to use the concepts of calculus, that is differential and integration we may have to use. So we are very safely using very small heights, which are all our experiments, all our blocks, pulleys and inclined planes, they are on the surface of earth only, so that there is no variation of g, and we can safely use directly, that is a constant force mg, and we can directly use, that is potential energy is equal to mgh, where h is the height from any arbitrary reference level. This is our choice. We can take the surface of earth as our reference level, I can take this level as my reference level, and we can proceed to do our questions. And kinetic energy is the energy because of motion, and this is half mv square. So this is half mv, that is velocity you say, or the magnitude of velocity, that is speed. This is always going to be positive, but when we say mgh, that is potential energy of a body, is mgh. M is mass of body, g is acceleration due to gravity, h is the height from the reference level. If this is the reference level, it has been taken, and the body is at the reference level only. So what is the height from the reference level? It is 0. So what is the potential energy of this? It is 0. If it is over here, then height from reference to this, it is positive. So potential energy of this is going to be positive. mgh is, h is like this. If it is below this, it can be negative also. When height is from this reference level, it is in the downward direction, it is over here, it is below this reference level, then the potential energy is going to be negative. So potential energy, it can be, when we talk the gravitational potential energy, or directly known as potential energy, it can be positive, it can be negative, it can be 0, it purely depends on the reference level. This is, we say, reference level. If body is here, h is here, so potential is positive. When it is over here, the reference level, height from the reference level is 0, so potential is equal to 0. When it is over here, so h is going to be negative, so potential energy is going to be negative. So potential energy can be positive, it can be negative, it can be 0, but kinetic energy is always going to be positive.